All right, so in this video, we're going to be talking about Velo AI, an agentic AI agent which is able to generate complete marketing campaigns with just one simple prompt from the user. So it has a bunch of tools under the hood which is able to use to come up with these campaigns, from audience research, the content generation, a suggested posting schedule, as well as, image generation for coming up with creatives for the ad campaign, right? Now, this whole thing started for me as part of going on a holiday, and I didn't know what to do with the holiday. I was like, okay, might as well work on a project. And I remember a project that I'd seen from Alex the Dev where he was using AI agents basically in Golang to do stuff with like tool calling and all that. I was like, really interesting. What if I try to implement something like that using Python? And I just thought about, maybe putting it together with a use case, a business use case, so marketing stuff. Maybe ChatGPT helped with the idea. Haha, I'm not gonna say it, but yeah, ChatGPT helped with the idea. Now, this whole thing is important from a development perspective because I tried my best to not use a lot of libraries and things, just to keep it raw and simple so that the real logic about the agentic AI stuff be clear even to me, because it was like a learning process for myself. Now, instead of talking about the code and the platform, which runs on Telegram, by the way, uses Telegram as the user interface, I'm not going to just keep talking about it. I'm just going to show you, because that's what this video is about. So let's get to that. All right, welcome to Data Code. We'll talk about AI, machine learning, data science, AI, data engineering, signal processing. Is that an orange? Computer vision. Deep learning. AI, NLP, AI. All right, so here's the repository for Velo AI. Everything is here. I'll paste the link in the description of this video. Right, here's the folder structure, dependencies, and all that. And then, as I said earlier, I tried to just make it vanilla code, except for the Telegram interface, of course, because that would have been like another project on its own. So yeah, except for that, every other thing was just basic code as much as possible. And then here are some basic steps to get this up and running on your own machine. So it's fully open source. You can clone it and make some improvements to it if you want, because obviously this is not like completed or anything like that. So could do stuff around unit tests, crazier prompt engineering stuff, and because it's a modular build, you can actually replace the models with maybe, instead of using the Ollama local models, you could use something from OpenAI, and then for the image generation stuff, you could plug it into Sora or any of the other image generation models out there, right? You could do more stuff with the Telegram interface, maybe build a web interface instead, and then have it have some API endpoints that will point to the generation and other things like that. So yeah, just play with it. Credits to Alex the Dev, like I said earlier, and ChatGPT. All right, so let's just get into the code here. First, I'd like to just talk about the architecture. So it's basically 5 agents. Now there's the supervisor agent here, and then we have the audience research agent, the content agent, scheduling agent, image generation agent, and then a web URL tool that can just be used to call any web URL that the model thinks it needs to call. So the supervisor agent has access to this tool as well as all the other agents, right? And then there's a database for persistence of the audience research message, the content, schedules. The images that are generated are saved to disk, right? So that's another thing that could be changed. Maybe you want to store that to an S3 bucket on AWS or any other cloud storage service. Image generation is done with Stable Diffusion, and for the LLM stuff, most of it is done with either Llama 3.1 or Mistral. So for the Telegram interface, there's basically a polling service that pulls messages, that awaits messages from the user. And if there's a message, it pushes it to the message handlers, parses through the logic. If it needs to push it to the LLM, that's the supervisor, it does that, and then the response is then pushed back to the user. And so this implementation gives back a structured response to the user by fetching all these artifacts that have been generated by all the different agents. It then couples that into one structured output that is then sent to the end user. Now I'm just going to be referencing my notes here. Okay, so now that we're done with the repository overview and architecture, I'll just like to go into the services. So we have the Ollama client here, which is basically communicating with the Ollama API that's running locally. So I'm running here on Linux. So normally this could also be a container, right? So for most of the modules that I've seen in the architecture here, Stable Diffusion is running in a container, Postgres is running on a container, right? So you could also containerize the app itself and then the Ollama stuff. But for me, I had Ollama that I've been using for other things, so I just went with that. No need to stress. All right, so basically pass the model name, the message, role, content. I think it's also going to be false here. You could just play with a lot of things, right? Then if there are images, you could do that. Tool calls, very important, and then tool names and stuff like that, right? So send a message, you could do a send with tools. So I just implemented a bunch of ways to reach out to the Ollama client. Now, send with tools is basically what the supervisor model uses, and then send with tools and structure is what I'm using for the specific agents that are supposed to just have one particular task that they're doing, because I wanted to return that specific type of response back to me, as you'd see as we go further. Now, persistence is empty because I kept on tweaking my approach to the project over time. So you'd see some empty modules that I ended up not using just by realizing they were not really important anyways. So for Stable Diffusion, same thing. We're sending a message to the automatic endpoints, and I'll show you that all those endpoints, how they're defined and everything in the config files later on. Now, something interesting that I had to deal with was memory management for the GPU. So, you know, Ollama uses the GPU. Stable Diffusion also wants to use the GPU, right? And so I had to do some memory management here to say, oh, flush the last model that Ollama has used so that there's enough memory space for Stable Diffusion to come into the same GPU and do its thing. So if I had multiple GPUs, I could have just maybe assigned different models to use different GPUs, but I have just one. So I have to do that, you know, and obviously to introduce a little bit of latency, but at this level, you know. And then sometimes in the process of trying to initialize the Stable Diffusion model, if it doesn't recognize that there's enough space, it would crash. So I just did another logic here to reload the server basically through the endpoint. And then so this is how the request looks like for the Stable Diffusion endpoint. This is the JSON payload. Just a bunch of parameters there. You can go in and look at it properly on your own later. Okay, so I'll just go into the agents and the other configurations. Here are the agents. I'll start with the supervisor agent, and so I just defined a class for it, and here I'm defining the tools, and I'm setting them as a list of callables, or as a dictionary of callables. So each tool name is mapped to the callable, which is the tool or the function rather that implements what that tool is supposed to do. Now, defining it this way makes my life easier, because when I'm trying to parse the tools later, I don't have to do a for loop or an if else statement when I'm checking by tool name, I'm simply going to call to this mapping. So you can see tool.function.name. Okay, I think this is probably going to be a good place to go into the types and just show you what's going on here. So to make my life easy in terms of just navigating all the data that's moving around, I defined a bunch of types here that just make it that I can parse the data with a logical approach all through the application. All right, so a tool call has a function tool call, and each function tool call has a name and its argument, right? So that's where you can see that tool.function.name and stuff like that going on. So you can see here, this is for a tool call, and then for the actual tool itself, it's here. So for a tool, you have the type, the function, and then the function has a name, description, parameters, and then each parameter has a type, properties, and so I didn't just come up with this arbitrarily. It's actually part of the Ollama API documentation. It expects a particular structure for tool calls and messages and stuff like that. So if you look through the JSON schema of what it expects, then you can infer these types, right, just to make your life easier with the rest of the code logic, so that as you're receiving a response from the model, you can parse those easily. So you can see that this kind of gives a better look as to what's going on under the hood, as opposed to maybe just using a library to just say, oh, call, send message, get the tool calls, return. Now you're actually getting a better understanding of what's going on under the hood, and you have to parse through this data yourself. So, and you're parsing now, because of the way I'm using it in this application, I'm able to parse it in a way that suits my particular set of needs. So there's not a lot of fluff or overhead in terms of boilerplate code elsewhere that I'm not going to be using, right? So it just means I'm loading less into memory and things. Hopefully that's a benefit. So there's a bunch of types that have been defined here for the agent stuff that you see as we go along. All right, so that's the supervisor, and then the scheduler agent. All of these are basically API calls to the Ollama endpoint, but then each of the tools have a separate system prompt as defined in the YAML file, configuration YAML file. So you can see different prompts for them, output JSON formats, which I will also show you later. Now, to go into the logic of it, let me just start with tools. Okay, so the first thing we're doing is that as we're trying to make that call, we inject the system prompt as the first message going to the model, right? And then we append whatever message the user has sent in as a prompt through the user interface. And then we receive the response, parse for tool calls. So while tooling is still true, and the number of, so we have a retry logic, right? So in case a tool call fails, it's able to try again and stuff like that. So we take them one by one, and then we get the result of that tool call. So if you go into this get result, I just want to take one implementation. The rest of it is basically going to be more or less a repetition. So I'll just use this one as an explanation for the rest of the code. Okay, so within get result is expecting the callables, as I said earlier, which is a dictionary of all the available tools and their callables, right? That's the function that is actually supposed to do the work. And then the tool call itself, the history, that's the message history. It's going to pass a logger because I'm doing the logging here just for, is observability the right word? Possibly. And then, so campaign ID and chat ID is more as part of the persistence side of things. So I kind of did an agile build to this. So I built in layers as more requirements were made obvious to me, and then went back, modified, and stuff like that. So maybe that's what informs my explanation, is also trying to follow that flow, right? All right. So for call arguments, we're going to then fetch the call arguments. I'm just going to go here. So what fetching the call argument does is we're checking to see if there are arguments that have been stored to file, because for each tool call, there's an output, right? And something I noticed in the process of working with the language model is that a particular tool might return an output that is required for the next tool, but the language model kind of modifies those parameters a bit, just because of, it's a probability machine, right? So what I then did was to save those responses to a database, and then for the next tool, I'm just going to check the artifact generation history to say, okay, what was the output of the previous tool, and then take those outputs as the inputs for the next tool. So that's what fetch call arguments basically does. There's a whole match case logic here going on, just to know what to pull from the database. And then there's also schema validation for those outputs that are generated by the agents. Okay, so let me go back to the core logic of getting a result. So here's what happens. We get the call argument, we create the task on the database and all that. And then, so here's the cool part of it. Using that dictionary now, I have my dictionary of callables, or the functions, right? And then I just take the tool call, get the function name, right? And getting the function name from the callable is already the function. And then I simply pass in the call arguments. So whatever call arguments the LLM has passed for that function are just going to be flattened here and passed to that function, and then we call that function with those parameters, and we get the results. As simple as that. So I don't need to know what tool the model, within this get result, I don't need to know what tool the model is calling. I don't need to know the parameters, and I don't need to do an iteration of if else, because I just thought about it. The number of tools are going to keep increasing, assuming the development continues, right? So do you want to keep updating those if else statements, or just have a function agnostic, parameter agnostic approach to the entire thing? So that's what this one line of code does. And then we do the schema validation, register, we do the schema validation, and then if it's an image generation workload, we update, let me see, okay, yeah, the image output paths, right? And if that's not the case, then we update the text outputs into whatever task has been created. Now, that's also part of the persistence side of things, which I'll be explaining later. So now let me just go into the config side of it. So I've shown you the config YAML file, so you can see the stable diffusion URL for automatic quadruple one. I'll just call it that. Then this is the model, and then the output paths for any artifacts that are generated. And then for Ollama, this is the URL. So because Ollama and OpenAI follow the same paradigm, basically, in terms of like the API structure and things, it's just going to be a minor change to swap to an OpenAI model. It's going to be a case of replacing this URL with the OpenAI API endpoint, and then obviously you probably have to do stuff to check your API key and stuff. So, but really the client logic in terms of how the message is passed and things like that will not really change. Okay, so that's a cool thing. And then, so same thing really applies to the scheduler agent. It follows a very similar logic, but this time the only tool called here is just the web connector. Now the creative agent is a bit different because it's now the image generation bit. So we're just making a call to the image generation endpoint, saving the image, and just to avoid duplication of records, we clear the save path if you're running for the same prompt, right? That kind of thing. Content agent looks similar to the supervisor, but this time is using send with tools and structure, right? Because with the Ollama endpoint, you're able to define the structure of the output. Okay, so let me go to that under types. Yeah, campaign. So no. I think it's still under agents. Yeah, it's under agents. Okay, so you can see content generation output. This is what we're expecting. We're expecting to have ad copies, emails, social posts, right? And for the social post, this is what we're expecting it to have: platform posts for the emails and ad copies. So everything, all the types are predefined. So we then pass the JSON schema of this particular output as the output structure of what we want to come out for example, the audience agent. So here is itself.output format, audience agent.model JSON schema, right? So we're passing this within the call to send tools with structure. Let me pull that up. Okay, so you can see it's sending the model, message history, the tools, and then the format. Okay, and then within the config .py, so this is where I'm introducing, so all the things that have been defined in the config YAML file, this is where I'm introducing them into the Python ecosystem, right? I'm importing all those things. So my Telegram token, database details, model stuff, and then, so as you can see here, within the system prompt, I'm also injecting the model JSON schema, just because this model it's a local model, it's not that smart, so I wanted to see it twice. So I'm passing it within the system prompt, and it's also going as an output format structure during the API calling process, just two-factor authentication. Let's get this thing working, right? So simple stuff there. All right, so I'm just going to move to the database side of things. So I told you that we started doing stuff around persistence, all right, just to make sure that everything that's being generated is kept in memory. And it's not really, now, if you built out a web UI where you have to handle like state management and things on your own for message history and things, then this persistence also comes in handy, right? So you can pull entire campaigns and all of this data to populate the chat history and things like that. But Telegram already has like message history. So in terms of what the user sees, for me in this case, I'm not using that data. Rather, I'm using it for ensuring the quality of responses that the model returns with each tool call, so that I'm passing the actual responses that were generated from the previous tool call, save it to the database, and then pass it during the next tool call. All right, I'm doing migrations with Alembic, so that's good because I kept changing the schema and things like that. So all that configuration and things just going on here, versions, That's a database setup conversation. So for the services, we have the artifact service. So we create artifact, read by ID, just basic CRUD stuff that you can check out for database things, create, read, update, delete. Same thing for campaigns and same thing for tasks. So that's the paradigm, right? So when the user creates a campaign, there's a campaign ID, and then within that campaign, there are tasks that are being run. So is it making a tool call, calling another agent, or is it making a tool call to the web tool, stuff like that, storing that. And then for the artifacts now, it's storing details about what was generated from those tool calls. Now, really, I'm just using it for only the image side of things, because for the other tools right now, they're generating just text. So it can as well just be part of the JSON output of each of those tasks. But imagine we added something like video generation or audio generation. So you still want to use that artifact table to understand where all this data for each of the tasks is being kept. A good reason for this would be in case, imagine integrating it with an S3 bucket. So you want to know what the link to that artifact is, right? So you'd use that. So very simple, logical way of just managing all the resources being used and consumed in the process of coming up with the campaign. All right. Next thing will be the Telegram interface. So Telegram interface, yeah. So there's basically the bot. This is just what does the polling stuff. Then the real work happens with the handlers. All right. So there's a bunch of handlers here. Start, where the entry point into the bot, all those things. But the real one, or the most important one that I would like to focus on, will be this new campaign handler. So this is where a bunch of the work comes in. So there's a logic to handle an empty prompt. So if you provide an empty prompt, it just returns a message to let you know that it's an empty prompt. You can't do anything with that. And then it sends you, if you send a valid prompt, it sends you a quick message just to let you know that, okay, it's cooking something behind the scenes, just wait, right? And then what it does here is that it calls the supervisor, initiates an instance of the supervisor with your chat ID, and then does a call with start with tools. And remember I said they start with tools and then start with tools and structure. So supervisor uses start with tools because it doesn't really need any structure. It just takes all that feedback back and organizes the content for the next tool that it's going to call and stuff like that. All right, and then we're doing some assertions here. So to validate that the campaign was created successfully, and then now we're loading the results of the campaign generation process, because like I said, we push everything to a database and then retrieve the structured response and then return it to the user. All right, so here's what loading results looks like. Is under the bot handler utils from the utilities module. So it reads all the tasks by campaign ID. So it uses the task service from the database to read all the tasks by campaign ID. And so it gets the audience research output, content generation output, and scheduling output, and then validates the schema again, just for completeness, right, of all of those outputs. And then for each of them, it does a structuring. So there's a bunch of HTML stuff going on here. To be honest, I vibe coded most of this because Jesus. Okay. Yeah. So it just does like a pretty print of all that data from the database, right? And then returns that to the end user here from the handlers. That's what comes back as load results. And then we take that result string and pass it to another message, which goes back to the user. And then for the images that are generated, we use another helper function here. Let me see, yeah. Load images, just to load the images based on the chat ID, campaign ID from the local storage, right? Pulls them, and then in the handlers, it comes back here and then does send media group, which is a functionality, from the Telegram bot to push out the images. So send the text first and then send the images. So that's pretty much it. I think that I've been able to go through, I believe I've been able to go through the basic workflow of how this works. And then, so now I'm just going to do a quick demo of how the chatbot works, the campaign generation bot works. All right, let's jump right into it. Control J. Oh, what have I done? Control J. I'm just going to check with Docker here quickly. Oh, yeah. Okay. One more thing. I'm just going to show you, but it's nothing serious though. This is the Docker Compose for the DB. So all I have running here is just the DB Postgre. Okay. And if you follow the instructions completely, yeah, you should have a separate repository, or should I say a separate folder that would have your stable diffusion Docker Compose running here. Okay, so everything that you need is here from the installation. Let me show you here. Here are the steps. Installing. Yeah. Okay, yeah. So in a separate folder, you just run these three commands to clone the repo. I'm assuming you have Docker already. Clone the repo, download you run this to download the model files, and then you run this to spin up the instance of stable diffusion that will make this entire thing work. All right, so let's go back to this. I'm just going to create a new terminal, delete this, Control J. Okay, so here's a quick start. I'm not going to copy everything because I'm already in the Velo directory. I'll just copy these three. Control C. Control Shift V. Boom. All right, so we started the stable diffusion container, started the Postgre container. As you can see, they're both running. And now, yeah, so there's a little bug. I don't know what happens. Sometimes it runs into a something never awaited error, but it's not all the time. I'll have to debug that, but okay. So let's just run it again. Let me see. But this time, since the Docker container is already up, I'll just run the script to start the Telegram bot again. All right, so it looks like we are up. Now I'm going to open my Telegram. So I tried to play with it earlier, so I'm going to open my Telegram and just say start. Okay. Are we not awake yet? Timed out. Let's try that again. Bugs. So until the day you want to run it, you start discovering things. But let me just restart the server. Let me just restart it. Okay. All right. So create campaign. All right. So I guess we're good now. It's probably one of the race conditions. I don't know what that is about. Probably have to look for a better implementation for the polling service and stuff. But yeah, help, and then about, just simple. So create a summer ad campaign for eco-friendly water bottles. Let's just use that. Control Shift C, Control Shift V. What's happening? Control Z. Okay, let me just type it out. Okay, yeah, so you can see it sends a quick message to let me know that it has started the generation and should be ready soon. All right, so I'm just going to pause the video and then show you when the response has been generated. But instead of pausing, I guess this would be a good opportunity to also show you what the logs look like. So for the Telegram bot service, you can see it's telling me that it has gotten a message from this chat ID, and then from services, so you can see that this is 10:48. This is the time right now. It's running a query with the Llama 3.1 model, and if I go to agent logs 10:48, so you can see starting a campaign for prompt, create an ad campaign for eco-friendly water bottles. So I guess let's just look at this together as it runs. All right, so you can see agent supervisor agent with these parameters has made the call and is running. It made 4 tool calls, and this is the tool call order, right? Audience agent, content agent, scheduler agent, and image generation agent. Now it's calling this tool, the audience agent tool, with these arguments. So let me just close this here. All right, might as well close this just so we have enough screen real estate to see what's going on. Created some ad campaign. Ad campaigns is 3. Yeah, I got some of my friends to test the app, so a bunch of campaigns have been run with it. So you can see the results from the audience agent. So keywords, interest, and pain points. This is this. Now it's using that data to call the next tool, which is the content agent. It first called the audience research agent. Now it's calling the content agent with these parameters from the last one. So the interest, keywords, and then this is the results from the tool content agent, which is add copy. So you can see channel is Facebook, and then the content, and then there's a bunch of them there. So channel, Instagram, content, and then emails, title, body, just like that. Very cool stuff. And then it has used that information now. So it passes all that information into the scheduler agent. And this is the schedule. So platform, content time, date time, and now it's calling the image generation agent with this prompt. So if you've used Stable Diffusion, you have the prompt and the negative prompt. Oh, I just realized I didn't even show you the tool structure. Yes, so let's even go back to that. Whilst that image is being generated, let's go back and look at the tool structure. Velo agent tools. Okay, yeah, so apart from get results, so you can see this is how the tools are defined. So scheduler tool, type 2, I told you I have those classes types that I've already defined earlier. So, and it helps you also to not miss stuff, right? When you're defining like a tool, for example, your ID is able to let you know if you're doing the right thing or not, just because you'll be able to define that particular tool structure. All right, so in the tool, typically you define the type, the function, and then the function has a name, so that's scheduler agent, and you give a description. So the LLM uses this description to know what tools to call and stuff, right? So, for example, the scheduler tool generates content delivery schedule for different channels based on the results. Oh, Velo AI has generated our campaign, so, but I'll get back to that. I just want to explain the basic structure of a tool call. And then we have the parameters here, which for this is a type of object, and then the parameter name is a prompt, and this is the property. So this is like a dictionary of the properties that this function would take. So the prompt, the type, and the description, add copies, the type, Now this one is supposed to be an array, so define what each of the type of elements that's supposed to be in that array, and then a description of it. So everything goes here like that. Same thing has been done for the others. Audience, your color. Now this gets weather is what I defined from when I was still trying to experiment with the whole thing. I told you I followed an example from Alex Dev, so I just wanted to get that basic scaffolding and then started to expand the scope from there. So that's basically, this was an experimental tool. All right, so that's basically what the tool calling structure looks like. Structure of each tool, and then then the rest of it, which I've discussed earlier, get results and all that. All right, so let's go and look at what the output looks like. All right, so you can see here's your ad campaign, audience research, the keywords. I mean, we saw this in the terminal, right? Eco-friendly, what about those, and then so here are the ad copies with the proper structure. So this is an ad copy for Facebook, ad copy for Instagram, an email, a social post for Twitter, a social post for LinkedIn, and then the creatives are loading up. Now, like I told you, the image model is not the sexiest because my GPU is not all that, so I kind of like had to bottleneck it just so it would run on my machine. But this is like a proof of concept. This is really what it does. All right, so this has been Velo AI, runs on Telegram, and let's see if our claim of 2 to 5 minutes was honest. So 10:48 we called it, and by 10:52 we got our answer. 4 minutes, right? And then a minute later, just because of bandwidth issues, my connectivity is not all that here, so it took like about a minute for the images to drop. So exactly 5 minutes for the market research, content, scheduling, and images. And as you'd imagine, if this was done with like a state-of-the-art language model API, it'd take even a shorter time because running locally means we're limited by the capacity of my machine. All right, so that's basically it. I'd like you to explore the repository, see how you can customize it, play with it, do something with it, maybe create a clone of it on your own laptop, play with it, generate stuff, and drop in the comments your thoughts on this. Yeah, I think it's been a good time. All right, so now we've come to the end of this video. I'm pretty sure that you enjoyed this video. I don't know why, but I just know you enjoyed this video. So I'm gonna want you to like the video because I know you liked it. Come on, and subscribe for more because Data Code Pie is all about Python projects around data, AI, NLP, and all those things, right? I mean, you probably saw the intro to this video. AI. It's all about AI and stuff, right? So like, share, subscribe, share to your AI friends, your AI enthusiast friends, your friends that won't stop talking about ChatGPT and stuff like that. They probably find this video interesting. And just people who want to come into the AI and data space, this channel is really just that opportunity to see how projects could work, like just from the perspective of someone who's also like growing in the field and stuff like that. So yeah, for the umpteenth time, like, share, subscribe to Data Code Pie. Now I'm just going to copy this thing that the Prime agent always does. The name is Data Code Pie.